Hi, so I serve as Chief Decision Scientist for Google Cloud, and I work on decision intelligence. And what decision intelligence is, for those of you who are statistically minded, it is applied data science augmented with social and managerial sciences, essentially for the purpose of the reduction of type 3 error. Remember your errors, data scientists? Type 1 error is incorrectly rejecting the null hypothesis. Type 2 is incorrectly failing to reject that null hypothesis. And type 3 is correctly rejecting the wrong null hypothesis. In other words, all the right math, all the right data for entirely the wrong question. So that is what we try to avoid in decision intelligence. We actually think about the entire process rather than the careful creation of general purpose algorithms, which may or may not be useful to someone later. So it's very business-minded. It's very end-to-end. But now that I've explained myself and what my strange title is, I'm going to talk about my actual presentation, which is about the future of AI, the present state of AI, and why we should even be excited about AI. Now, first things first, can we please stop this whole robots thing, this whole appeal to science fiction? In the good old days, when AI wasn't useful for anything, right? Yeah, you know it. In those days, you had to make the appeal to science fiction. So that's where your grants were going to come from. But today, it is incredibly useful, and it's here. But the way that business tends to use that term AI doesn't refer to human-like stuff with a mind of its own anymore. And in fact, I rather prefer it when we use the term HLI, or human-like intelligence, for that. But the AI that you see today, the really useful thing, I like to joke that it's more about thing labeling. And I'm going to explain that to you in a little bit. But first, let me kind of show you what the point is, just so that we can reorient ourselves and stop thinking about this as the recreation of humans. So here is a picture of my pet Huxley. And when you look at this, you take in some fairly complex information through your senses, and you get the label for that as if by magic. Or you don't. My clicker seems to be not working. First the clicker, then the louder. I think that, yeah, just click back on the presentation. There we go. Let me see. Yeah, it works again. No more mouse. I'm scared of the mouse. Okay, good. Right. So, you took in this information as if by magic, and you just know that that's a cat there. You don't even know how you know that that's you do. And if I show you this one, you're not fooled. You still know that it's a cat. You even know that it's probably the same cat. Now, think about automating this task, right? Because why do we like computers? We like them to do stuff for us. So the tradition of automating this task is that we're going to communicate in some way with the universe, right, programmers? You know that this is how you do it. You channel the universe in some way, you think really hard about the problem, and then you handcraft the recipe that gets the job done, that turns the pixels into the label cat. But I want to ask you, what must that recipe be? I mean, what did your brain actually do with those pixels? You don't even know, do you? Because your brain has had the benefit of eons of evolution, it just does it. You don't know how it does it. So how on earth are you going to handcraft that code? Wouldn't you much prefer to say, hey computer, here's a bunch of examples of cats, here's a bunch of examples of not cats, now you go figure it out. That is the essence of machine learning and AI. That's the point. Not this flashy robot stuff, but the fact that you can now express your wishes not only with explicit instructions. That was the only way to do it in the past. Now you can communicate with examples as well. And think about it. In your daily lives, you like to use both modes of communication. Sometimes you want to tell someone exactly what to do, every little bit of it. And sometimes you want to say, hey, look at a bunch of this stuff and like figure it out because you're smart, right? AI, machine learning, unlocks that second mode of communication. It is a different programming paradigm. It ungags us and lets us talk to computers that second way, the way that we sometimes also choose when we talk to one another and when we teach one another. And here's the beauty. Here's why you should be excited by AI. Every now and then, a task ends up being so complicated that you cannot come up with the instructions. They are ineffable. You cannot express them. So you cannot get it done the traditional way. AI is about automating the ineffable. This is about saying, I don't actually know what the steps are that get me from the pixels to the label. Never mind. I can perform the task lots and lots of times. I can make a whole bunch of examples. And then the computer can figure it out from patterns in those examples. That is why we should be excited. Now, at Google, we use AI a lot. In fact, I can't even think of a single one of our consumer products that doesn't have machine learning or AI in there somewhere. So just a few of the familiar examples. The spam filtering in Gmail, making search better, more relevant, more awesome for you. Then that magical moment in photos where you type in the word cat and all of a sudden all of the cat photos that you took just pop up. So we use this a lot at Google, but I actually want to move away from how we do this, what we do with it internally. I want to talk more about how it's actually accessible to everybody else and all of you. So why now? Why is it in your hands now? And why are we hearing AI this, AI that? It's not because of the algorithms. In fact, that thing that you guys are calling AI, deep learning, a kind of machine learning where the algorithm is deep neural networks, that thing is a child of the 60s. These things have been around for quite a while. But what this is, at its core, is explaining yourself with examples, with data. And so it's all good and well that you have the algorithms, but if you don't have enough high-quality examples, you're kind of stuck. But today, the world is collecting data like never before, and that's only accelerating. So all of a sudden, you've got the examples to explain yourself with. But, so you've got this algorithm made. If you have, as a grad student, made this thing, you've pretty much put it together with like hope and sellotape. So there's little hope for someone who's not you to actually use this thing easily unless they're super dedicated. Unless engineers go and make tools out of those things that become easy for others who didn't actually invent the original one themselves to use. And today as well, the trend that I think we should all be watching, because this is exciting stuff, is a dramatic increase in people contributing to tools that make this space easier. And actually, in some ways, data scientists should wonder about how their jobs are going to change, because some of what they're really proud of, beating that computer into submission, some of that only comes from, is only necessary because the tools suck. And if you make them better, then a whole lot of that stuff goes to the speed of thinking. And it leaves the job. So you might want to think in your career as data scientists, what part of what you focus on a lot is going to stay there, that creative human stuff? And what part is just the drudgery that you had to do because the tools were bad? Because that will probably go away in the future. And then, almost most important of all, is you actually need the computing power to get all of this done. For some of these algorithms, you're not going to be able to run it on a large data set on your laptop. You're just not. And so the only way you were going to be able to give it a whirl in the past is if you went and built your own data center. But today, with the cloud, you can go and give it a whirl. The cloud is just someone else's computers, essentially. You go and you use someone else's data center for a bit, and when you're tired of it, you give back that data center. Much easier than building your own one just to try it out. And so really, it's a cloud story, this rise of AI. That is what puts it in your hands. And I'm really happy to report that the future is now here, and businesses are really using this stuff to get things done. So how do you find, how do you find use cases? I have a handy tip for you, because I find that this is one of the bottlenecks for businesses. What do I use it for? So here's what I want you to do. I want you to imagine that it's all a hoax. There is no AI. Instead, there is a bunch of humans sitting behind computer screens, all pretending to be the AI. You send them a cat photograph, and they send you back the label cat. Imagine that. And imagine that I had millions of such people for you. And I let you use this resource for almost free, except that there's a catch. You may not communicate with them by instruction. No instructions, no emails on how to do the task. Only a bunch of examples. But you can use them for almost free. Think about what drudgery you would cut out of your lives. Right? What repetitive nonsense do you end up wasting your time on that you could just show some examples of to these people, and they could start doing it for you? As you're thinking about that, you are coming upon the right use cases for AI in business. But wait. You don't know how drunk these people are, right? Don't just trust them with your important tasks. You had better pick tasks where if you care about those tasks being done right, if there is a right, not like, hey people, write me a poem, that's a different thing. But if you care about the task being done right and at high quality, you need to be able to say what it means to do that task right. And you need to have an idea of how you would score them if they did, say, 1,000 or 1,000,000 of these tasks for you. So that means the business decision maker has to think about it first and think about what they're trying to achieve. And the mindset that you want to have here is almost the mindset of constructing a board game. How would you score this board game? Which mistakes and which plays are the better ones? Which ones are the worst ones? What is the best, what is the thing you want to reward most and give the highest score to? So that's the way to find use cases. And let me give you a few examples of real things that are already being done. And I called this thing labeling. So let me show you some thing labeling in action. So for example, you could use it to make food safer by labeling ingredients in baby food as safe or spoiled, so that they don't get into the finished product and harm out kids, or making high-quality satellite image maps. They're not so high quality if they are covered in clouds, and so you need to remove the cloud cover, but the snow is working as intended. So would you like to go and manually examine every white pixel and pick off the ones by hand that are clouds? I don't think you want to do that drudgery. Wouldn't it be much better if you could have the computer propose a whole lot of changes for you, propose a whole lot of clouds identified, and you could just supervise that and say, yeah, those I like, you made a mistake over there. Then, improving medical screening. Of course, if doctors could perfectly screen every patient for free all the time, we'd prefer doctors to do it, but if the choice is between no screening at all or maybe helping to automate things so that more people could get their diseases caught early, wouldn't we prefer to have some assistance of this kind of medical diagnostic thing labeling? And again, you'll have doctors having the final say at the end of the day. Then creating smarter homes. For example, you could have a camera that checks who's come up to your door. This is real, and this camera does this. And if this is someone not recognized, it keeps your house safe by locking the door automatically. Of course, these things do make mistakes sometimes. Sometimes it will keep you safe from Batman when you come up to the door. Then here is thing labeling on steroids, so labeling video footage and figuring out what's in the scene. More kinds of labeling. You know, you think about unsupervised learning, and you're like, Cassie, you keep calling this thing labeling. Unsupervised learning doesn't fit the bill. Sure, it does. The label is group ID or usual and unusual, normal and outlier. So you could do some anomaly detection to catch things like fraud and money laundering done by banks today. Improving communication. You could automatically caption the speech that I'm giving here. And you could help people who aren't able to hear me, maybe because the microphone's off, to see what I'm saying. Or you could use it to translate idiomatically from one language to another one. At Google, we use deep learning to power our translation. We also improve customer service this way, so we've announced Contact Center AI, which really helps with your contact centers, with the user experience there, and filtering down to get the most relevant things to your human agents to make their life much more efficient and better. And then more reducing drudgery with things like smart inbox. Instead of typing out the same thing every time, it'll give you some options, and if you like one of them, you hit that option, and you don't have to type that out, right? Makes things a lot faster. I bet you don't like to repeat yourself, and this helps you not do that. Right? Then, an example that we really love to talk about is increasing the energy efficiency of our data centers. Now, data centers are some power-hungry things. They eat quite a lot of energy, and so if we can increase the energy efficiency, we can really reduce the carbon footprint, reduce the cost. And so the approach in the past used to be to handcraft that cooling system control code, and then have data scientists, analysts, profile that data center and find places where we could propose some adjustments and improvements. And when we did it that way, you could get like a 1 or 2% improvement in energy efficiency. And that would be amazing. That's a huge cost savings. Then, when we let the AI system handle it, take a moment to imagine what the energy efficiency improvement was, those who don't know this story. 1 or 2% with human data scientists. What are you thinking? 5, 10, 20, wow. The answer is 40. 40% energy efficiency improvement. That is huge. That is amazing. Money saved and incredible help for the environment. And then you can also do amazing things with sequences. So thing labeling, the label, you could be a little bit more creative about what a label is. A label could be a sequence or a next move in a game. And you end up with these wonderful things where you win at a game like Atari's Breakout game by tunneling up the left side to get your score to go up as quickly as possible. And you could use it to beat the world champion player at a really complex game like Go, where people had before been saying, hey, there's no way in the next 10 years that you're going to build an AI system that even plays Go decently. Never mind, beats the best. So this is also about building the future. Yeah, okay, so I've got a robot example in here, you'll have to excuse me. Or building the future. Label here is what to do with the car, how to move the steering wheel, what's my next move. All of this is just a creative way of thinking about thing labeling. So it's got a lot of promise. There's a lot of stuff we'd like labeled automatically where we can't express the instructions directly. And the technology is here. So why on earth are businesses failing at this? What's so hard about this? Well, look, I've got a serious question for you here. Who here knows how a microwave works? Microwave oven. Well enough to build me a brand new one from scratch. Any takers? Microwave? All right, I see 2 hands, I'm impressed. Different question. Who here has never used a microwave to heat food? So what you're telling me is that you have no idea how they work and yet you use them anyway? Am I right? Well, that's okay, right? Because you're not going to trust the microwave by reading its wiring diagram. You're going to trust it because you're going to think about what you need it to do for you, and then you're going to check that it delivers that. And that is exactly the same thing as what you're going to do with AI. Now, the reason that businesses end up failing here is actually that they don't know what business they're in. Because what we don't talk about enough is that there are two AIs. There is a research side and an applied side, what we at Google are calling decision intelligence. The research side is the one that all the university courses are about. That's the one that has the really long history. That is about building general purpose tools for other people to use. So newer and better microwaves. And look, you need all those courses because how are you going to build a better microwave than this one if you don't know how this one works? Of course it's a 10-plus year training program. But a lot of you don't care about building microwaves. That's not what you're selling. You want to innovate in the kitchen. You want to cook. You want to run an industrial-sized kitchen at scale. And what you do is you hire 20 people with PhDs who have been building microwave components their whole lives. I mean, what could possibly go wrong, right? And if it doesn't go wrong for you, don't pat yourselves on the back for excellent decision making. You happened to hire engineers who, just by luck, ended up being great chefs. That's luck. That's not a plan. What was your strategy here? As we at Google like to say in our reliability teams, hope is not a strategy. Hoping that you hire somebody who's really good at building microwaves and that person just ends up loving cooking and understanding how to serve your customers, that's not a really good way to go about these things. But what we're doing in education anyway is just focusing on teaching the world to build more microwaves and teaching nobody how to actually cook with them. Now, we at Google are trying to address this and change this by training our personnel in decision intelligence in the applied side explicitly, and really owning the fact that this is an engineering discipline in and of its own right. Kind of like I like to say, just because you don't have to wire your own microwaves doesn't mean that opening McDonald's is easy at scale across the world. And there's a lot that you'll need to know. There's a lot that you'll need to know to understand what's worth making. What do your customers want? How are you going to check that you've delivered that? How are you going to administer your taste tests? How are you going to manage your ingredients, your data at scale? How are you going to process and prep and clean those ingredients and check them and figure out which ones are worth using? And then how are you going to tinker in the kitchen if you assume that there are warehouses upon warehouses of microwaves and you can go and get what you need, you don't have to rebuild it from scratch? Whole, huge, interdisciplinary thing. So let me give you a few bits of advice before I run off. How do you avoid the common pitfalls in the applied side of machine learning, the business side? First off, know what business you're in. If I leave you with one take-home message today, it is that you need to know whether you are cooking or building microwaves. And if you don't know, you're going to have some serious problems. And the business leaders are going to be saying, these data scientists are useless. Of course they're useless. You want to serve pizza, and they are helping you build electronics. Then, another piece is never forget the basics of learning and teaching. When we get all sci-fi about this stuff, and when we get all mathemagical, our common sense goes out the window, and I don't know why that is. What applies in the basics of learning and teaching that we all have some sense of because we all went to school still applies here. For example, we are in the game of expressing our wishes, of explaining ourselves with examples. So, of course, we're going to need good examples to explain ourselves with examples. And we're going to need enough of them. So, for some of these complex tasks, the more complicated the task is, the more examples you're going to need to give your student for them to learn this task. So you may need, at some point, to go to very large scale with your data. Expect that. Just because you have 30 examples in a spreadsheet does not mean that you are for sure going to be able to succeed. That's the first thing. The second thing is use relevant examples. Your data sets are essentially textbooks. And when you pronounce data with a capital D, that is like you saying, oh, I have textbooks, don't worry about it. My student will definitely learn what I need them to learn. Well, suppose you want a calculus-enabled student, and your textbooks have Japanese-English vocabulary pairs in them. Yeah, there's data in there, and your student will learn some patterns, but they will not learn what you need them to learn. And so I tell Google engineers to consider tattooing this sentence on themselves. The world represented by your data is the only world that you're going to succeed in. What's in your textbooks is the only thing that your student is going to learn. And so to tie into some of the things that the panel before me was saying, I'm going to summarize it as it's your fault, right? Those textbooks, they are written by humans, by engineers. They have authors, human authors, with human biases. They are influenced by our times. It is up to the business decision maker to open that textbook and make sure that what is in there is what you want to be learning. Do analytics on your data. Make sure that it's okay. And think about who those authors were and where those textbooks came from. It's not magical just because it's data. Please pronounce data with the lowercase d. And another part of learning and teaching, you want to know if your student can do calculus and can generalize beyond the examples they learned in class. How are you going to check? Not by taking their word for it because you think that they're magical because they have a brain. No, you're going to do it by testing them. And you're not going to do that by taking a scalpel and digging around in the wet stuff to see how the algorithm does it. You're going to do it by giving them an exam that fully and cleverly reflects the span of where you need that student to perform. And if they pass that well-designed exam, then you trust them, otherwise you don't. And please, for goodness sake, don't give them an exam full of the same examples that they learned from in class, because then they could just memorize their way to victory. That's what the whole overfitting thing is about. So have new data in a drawer somewhere that you can actually check whether this thing does the job for you. And if you pick people's models up, we at Google have a lot of ready-made recipes for you in our Google Cloud APIs. Even if you use our stuff, check it works in your situation. Give it an exam. That's what keeps you safe. And then kind of the final thing is the applied side. It's really a team sport. It needs a lot of different job roles to get it done well. It's not just your classic standard idea of the AI nerd. You want 20 copies of them and that's your team. No, you're going to need decision makers, you're going to need social scientists, ethicists, you're going to need program and project managers, you're going to need statisticians, reliability folk, engineers, software and AI engineers. You're going to need analysts. You're going to need a diversity here. And if you want to talk about one person as being the most important AI person on that team, it is not the AI researcher. It is the decision maker. Because it is the decision maker who sets the exam and who says how high the bar is. When your statisticians tell you the exam is passed on fresh data, all you know is that the student has passed the exam. If the exam was a stupid exam, that doesn't help you much. And you are in charge of figuring out what that exam should be and what it means to succeed. And so I really want to close with this idea. Decision makers, we haven't been training them because bad decision making was self-limiting in the past. You'd just do damage around where you were. But today, what all these big data technologies are is huge levers. There's no such thing as technology that's free of humans. It's just an echo of the wishes of whoever built it. But these technologies now, these huge long levers, they have at the end of them essentially the team's decision maker who said what was worth doing and why that was a good idea and how we set our performance bar. That one person at the end of a very, very long lever. I hope that that person has the skills to think about what they're doing. We are building here a proliferation of magic lamps. It's not the lamp or the genie that is dangerous. It's an unskilled wisher. And so I hope that what we understand is that we have to train you, business leaders, decision makers, to wish responsibly. That really is the key to success. Because the rest of it is really much easier than most people think. There's warehouses upon warehouses of these microwaves. You can take a lot of what you need right off the shelf and run with it. What you have to care about is what that exam is, setting it well. And so, with that, I hope that you are excited because your machine learning adventure awaits. Just remember, wish responsibly. Thank you.